Welcome back to part 2 of IMFA's new webinar series. As a reminder, this is part 2 of our 4-part series. If you missed the first one last week, we'll link the playlist in our description. Today we'll be discussing transfer molded Type 2 molded fiber. Type 2 molded fiber is likely the type consumers are most familiar with and is the largest volume of molded fiber globally. Special thanks to IMFA member Manfred and the team at SPM for the use of their photos and videos throughout this session. In the video, we'll see a single-face 2100, a 4-face 6000 running only one face as they're making a heavy product, and later a 4-face 6000 running on 2 faces. Most manufacturers of Type 2 machinery will use a model denoting a number of 65-gram filler flat 30 egg trays to illustrate output per hour, even if it's not designed to make a filler flat. At about the 2-minute mark in the video, you'll see a wet press in action at about the 12 o'clock point of the rotor. This has become a critical addition to Type 2 machinery. This is a single-face 2100 with 1 platen of molding and 1 platen of transfer, typically running at 6 to 10 drops per minute, capable of running about 2 tons per day. This is a 6000 with multiple faces tooled on 2 faces. This is typically able to put out about 6,000 filler flats per hour or 7,200 1x12 egg cartons. This is a 6000 with multiple faces tooled on 2 faces. This is typically able to put out about 6,000 filler flats per hour or 7,200 1x12 egg cartons. This is the wet press. This improves the quality of the rough finish on the back of the product and increases the solid content by about 2%, resulting in an 8% improvement in drying efficiency. There are typically 2 main types of machine design, the first being a reciprocating machine with a vertical travel in and out of the pulp that makes provision to swing the platen 180 degrees. This means it can either submerge molds facing down into the pulp or it can submerge molds facing up. These are extremely effective when manufacturers start making heavy-duty Type 2 packaging. More simple versions are designed to submerge molds facing one way or the other, not with the ability to do both. The second and by far most representative in the overall volumes of Type 2 globally would be rotary molders. We'll talk about that a little bit later on. Typical transfer molded Type 2 molded fiber is manufactured using 1 formation and 1 transfer mold with product wall thickness from 1/16 to 3/16 inches. Surfaces have one relatively smooth side and are oven dried. Dryer characteristics range from batch ovens to single-pass continuous 12-zone dryers as well as multi-pass dryers. Smaller machines successfully run multiple product designs on the same platen provided the geometry allows for reasonably even drying of all products. Now that we've talked a little bit about transfer molding, let's talk about the more common rotary molders. Typical product sizes start at about 100 by 100 by 10 millimeters and no smaller due to drying problems in the oven. When products get down to 20 to 30% moisture content, drying is much more difficult and becomes a huge limitation. Products can be up to 600 by 400 by 100 millimeters. It's important to note that 1700 by 400 millimeters is a very standard size for a Type 2 rotary platen. Machine vat pulp consistency is 1 to 2% with larger volume, high-speed machines, but typically closer to 1 to 1.2% consistency. It's important to avoid increasing consistency too much. The further from 1%, the greater the risk of poorer product quality. A typical cycle time in terms of drops per minute, 6 as seen in the video on the 2100 up to 80, and typically 3 to 6 products across the platen. This means that these machines can produce up to 480 pieces per minute. The 24-hour output on a typical machine is anywhere from 1 ton on a 750 reciprocating to 30 tons off a diamond rotary. What's fascinating is that you can't transfer off that machine with a single transfer die. Many companies out there will use multiple transfers to keep up with production. The energy sources we use are natural gas for direct contact and steam for indirect contact. Raw materials, just like with Type 1, are double-lined kraft, DLK, old corrugated containers, OCC, and old newspaper, ONP. Raw materials can also include pre- and post-consumer waste, with the latter requiring extensive cleaning equipment depending on the grade of paper. The industry has moved from its reliance on newsprint fiber to a kraft fiber. Molded fiber products are a great way to give new life to recycled paper products. Typical tooling considerations for rotary machines can have up to 12 faces with 6 tools across and 72 forming dies, so they're suitable only for massive volume, multiple year lifespan products. Many of you may already know Type 2 is specifically unpressed and becomes Type 4 after press. We'll talk more about Type 4 in the final session of our series. Type 2 shrinkage is impacted by many things including fiber type, drying profiles, and solid content coming out of the forming mold. It requires a greater understanding of your incoming raw material characteristics to make allowances to be built into the tooling to compensate for shrinkage. You can typically fit around 3.5 metric tons of unpressed egg trays into a 40-foot high cube container versus just under 8 metric tons of pressed Type 4 egg cartons, making it not ideal for global shipping. That concludes our session on Type 2 molded fiber. Join us next week as we learn more about Type 3. If you have any questions in the meantime, please reach out to us at info@imfa.org. Bye for now.